Hello everyone, today's lesson is about factoring the sum and difference of two cubes. So before I give you the examples, I have four here for you, two examples about sum of two cubes and another two examples for the difference of two cubes. We need to remember these two things. Of course, number one is once you have the plus and the minus, then you're good to go. But the terms that you're going to have should be perfect cube terms. So when I say perfect cube terms, when it comes to the variable or the literal coefficient, the exponent should be divisible by 3. Okay? So once the exponent is divisible by 3, then we know that that literal coefficient has a perfect cube. So here we have a 3, that's a number that is divisible by 3. The next number that is divisible by 3 is 6. 9, 12, 15, etc., etc. So every time you see those numbers, or literal numbers, yes, as your exponent, then we can use the sum or difference of two cubes. Okay, so I'm talking about the exponent. Now when it comes to the numbers, we need to make sure also that the numbers are perfect cube numbers. So what are the perfect cube numbers? Let's start with the smallest one, which is 1, because that is equal to 1 times 1 times 1. So 1 is a perfect cube number. There's not actually a lot perfect square numbers from 1 to 100. The next one after 1 is 8, because that's the product of 2 times 2 times 2, right? 2 times 2 times 2 equals 8. So 8 is a perfect cube number. The next after that is, so 3 times 3 times 3. It's obviously the next, which is 27. So 1, 8, 27. These are the numbers we want to see there, like in either of the two terms. The next is 4 times 4 times 4, which is 64, right? And then the next after that is 5 times 5 times 5, which is equal to 125. So there's not really a lot of numbers. 1, 8, 27, 64, 125. These are the common ones. But once you come to a point wherein it's greater than 125, or the product of 3, 6 rather, and the product of 3, 7, then just use calculator just to make sure to find the perfect cube number of the numerical coefficient. Okay? Now, let's apply the formula to factorize the sum and difference of two cubes. Okay, let's go to the first one. I have one example here for you, actually two. So let's start with the sum of two cubes. Here we have x raised to 3 plus 8. And just like the difference of two squares, we just need to find a and b here and substitute that to the formula. Now, let me just write the formula first. That's a plus b times a squared minus ab plus b squared. So we need to find the cube root of x cubed. So the cube root of that is, of course, x. But why is it x? We simply divide the exponent by 3. So 3 divided by 3 is equal to 1. Now, what about the cube root of 8? Well, like what you saw earlier, 8 is a product of 2 times 2 times 2. So the cube root of that is 2. So basically, our a is x and our b is 2, which means that we can rewrite x cubed plus 3 as x plus 2 times x squared minus x times 2 plus 2 squared. All right, and then let's simplify that. That is going to be x plus 2 times x squared minus 2x plus 4. All right, so it involves only two steps, and the first one is simply substitution. Obviously, before that, you need to find a and b by looking for the cube root of each term. All right, let's go to the next example. Okay, so we have 1 plus 27y cubed. So, okay, let me just rewrite again the formula for you. It's right here on top. So I'm just doing this so that you will clearly see later on the substitution part. So cube root of 1. What is that? Well, it's 1. What about the cube root of 27? Y cube. So for 27, we know that is a product of 3 times 3 times 3. So that means it's 3. And for y cube, that's 3 divided by 3, which is y. So this is our A and this is our B. Now that we know our A and B, we simply substitute those terms to the respective variable. So 1 plus 3y times 1 square minus 1 times 3y plus 3y square. So this is equal to 1 plus 3y. Or if you want to actually rearrange that, no, I will not do that. Just just so you see which one is the A and B. But you can actually switch the two. This is 1 minus 3y. 1 times 3y is 3y, and then plus 3 square means 3 times 3, which is 9, and then y square. Now, let's rearrange everything to standard form. So meaning this is 3y plus 1, and this is 9y square minus 3y plus 1. So that's how we apply the formula for the difference of, sum of two cubes. All right, so let's go to the examples for the difference of two cubes. Okay, so the only difference between the two formulas is are this two. So notice that in the sum formula, this is plus and this is minus. So for the difference formula, difference of two cubes formula, you start with the minus sign and then the plus sign. Okay. Okay, so what we have here is x cubed minus 64y cubed. Again, I will rewrite the formula first for you. Okay, so what is the cube root of x cubed? Solving for a here, that is x. Again, you simply divide exponents by 3. So 3 divided by 3, that gives you 1. For b, what is the cube root of 64y cubed? So for 64, it's 4. For y cubed, it's y. Right, there you go. That's our a and b. Let's do the substitution now. That's x minus 4y. And then x squared plus x times 4y plus 4y squared. All right, so let's finalize the answer and simplify this one. So 4y times x squared is x squared, x times 4y is simply 4xy, and then 4y squared is 4 squared, which is 16, and then y squared, so 16y squared. Alrighty. Okay, let's go to the last example. All right. Okay, so we have 8x raised to 3, y raised to 9. Now, if you look at the exponents here, 6 and 9, they're both divisible by 3. So that means we can use the difference of two cubes formula here. I don't know if you remember what I said earlier. When it comes to the exponents should be divisible by 4 in order for us to use one of the two formulas that we have here, the sum and difference of two cubes. And when it comes to the numerical coefficient or the numbers, it can be 1, 8, and then whatever, perfect cube number. Okay? Let me rewrite the formula again for the nth time. All right. So what is the cube root of 8? This is for a, by the way. X squared. 8x raised to 6. So for the numerical coefficient 8, cube root of that is 2. Now when it comes to the literal coefficient or the variable, x raised to 6, simply divide the exponent. Okay, the exponent 6 by 3. So the answer to that is x squared. Then for the b, we have the cube root of y raised to 9. So that's y. And then the exponent 9 divided by 3, that gives you 3. So now that we have our a and b, Simply substitute those terms to their respective variable. A is 2x squared minus y raised to 3, right? 2x squared minus y raised to 3 times a squared, so 2 x squared plus 2x squared times y raised to 3 plus y raised to 3 square. So here the final answer is 2x squared minus y raised to 3. 2x square is 2 square, which is 4, and then x raised to 4. So this is 4, this is x raised to 4, plus 2x squared y cubed. And finally, y raised to, multiply 3 and 2, that gives you 6. So there you go. That's how you apply the formula for the factoring of sum and difference of two cubes. Thank you for watching.